Hi everyone. So today's lesson is going to be on linear regression. And we did start looking at the vocabulary at the top of your note packet. I asked you to define, and we had a little discussion on some of the terminology for linear regression. And I'm going to be referring to that terminology throughout the lesson. But today, let's start off by looking at graphing a scatter plot. A scatter plot is really just a graph of points that we plot to see if there is any type of relationship between the points. So here's our first set. It shows the number of runs scored by a high school softball team in the first 7 games of the season. It says graph a scatter plot using the given data. So as you can see, I have given you an X and a Y axis, and on the X and the Y axis, I have the games on the X axis and the runs scored on the y-axis. So you do want to always label. And you also want to pay particularly close to your scale. The scale on the x-axis does not need to be the same scale on the y-axis. It's always important for you to look at that. But I'm going to go ahead and plot the data, and I'm going to put a little x next to games and y next to runs. That way I don't get confused as to what goes where. So for one game, I had 3 runs. And notice that I plotted 1, 3. And then game 2, I had 1 run scored. And then game 3, I had 5 runs. And game 4, I had 9 runs. Game 4, 9. Game 5, I had 12 runs. Game 6, I have 10 runs. And game 7, again, I had 12 runs. Okay, so that's a scatter plot. A scatter plot, again, is just a graph of points plotted to see if there could be any type of relationship. Now, I'm looking at these and I say that, it seems like as the games progressed, that the number of runs scored kind of went up. So it looks somewhat linear, but there's other types of relationships we could see. Linear is not the only one. We could see a linear relationship, meaning it's following either a path upward, it could be close to a line. You could also have a quadratic relationship or an exponential relationship, but that's what a scatter plot is. All right, so now how do we describe correlations from scatter plots? So now we're looking at a couple sets of scatter plots. Now, when I look at this scatter plot, I see that as I travel from left to right, the data is rising from left to right. And we would say that this has got a positive correlation. Think about how it relates to like slope, okay? A positive correlation. Whereas when the data is falling from left to right, as it is here, we would say this is a negative correlation. But I want you to notice that the correlations are actually pretty good because this one actually follows a pretty linear path up, and this one a pretty linear path down. But this last one, the data is kind of all over the place. It's not like a tighter fit, and we would say that this data has no correlation. When we're looking at correlation, we're really looking for a relationship, whether, again, it be linear, maybe quadratic, meaning it rises and falls like a parabola, or even exponential. Okay? And there also could be a situation where there's really no correlation at all. All right, so let's identify correlations. Let's think about what type of correlation you might expect to see. So the temperature outside and the amount of your heating bill. So I'm actually going to just draw a quick y-axis for myself. And so if the temperature, let's put the temp here and the bill price here, okay? As the temperature is getting hotter, what do you think is happening to your heating bill? Is it going to be rising or is it going to be falling? So as the temperature's going up, okay, so hopefully you're seeing that as the temperature goes up, the bill would go down, okay? So it would be a negative correlation. right? So as my temperature is increasing, my bill is coming down. So, or my temperature is going up, this way, the bill would be coming down. So it would be a falling correlation, so a negative correlation. All right, the temperature outside and the phone bill. Well, I'm thinking about this. Does the temperature outside even anyway affect the phone bill? So this might be a situation that there's no correlation. All right, now the temperature outside and the electric bill. Well, as the temperature is rising, my electric bill, which is my AC, is going to be going up. So this would be a positive correlation because it would be rising from right to left, whereas this one would be falling, okay? All right, so hopefully you can kind of get an idea of what I'm talking about with positive and negative correlation. All right, so we're going to choose the scatter plot that best represents the described relationship. So the age of a car and the number of miles driven. So think about age of car and the number of miles driven. What do you think is happening in terms of the data on the plot? So I looked at it and I was like, well, if this is the age of my car and this is the miles driven, as I increase in age, well, yeah, the miles are going to go up on my car. Now, there could be a year or a month that I don't drive as much, but it's still going to be a rising or a positive correlation. So I said graph B. All right, the age of a car and the sale price. Okay, so as the age of my car goes up, I think the sale price is going to come down. Because people don't want older cars, right? And I'll say sales price. So I picked graph A because it was a negative correlation. All right, and the age of a car and the number of states traveled to. Well, those don't really relate in any way. Can we drive cars of different ages in the states traveled? Yes, but it's not going to correlate to each other in any way. So I picked graph C, so no correlation. Okay, a couple more things. When we're describing this correlation, there's a value on our calculator that can help us, okay, called the correlation coefficient. On our calculator, that correlation coefficient is the letter R. And I'm going to show you that on the calculator, okay? But it measures the strength of a linear relationship. So we can only look at the correlation coefficient if the relationship is linear. And our calculator calculates it for us. But what does it mean? So the sign of R indicates the slope, okay? So meaning if R is negative, okay, R is negative, then it's going to have a negative slope, the line. And if R is positive, then it's going to have a positive slope. And that R value, it tells the slope, but it also tells the relationship, the correlation. So if it was a positive slope, a positive R value, that means a positive correlation. And a negative slope would mean a negative correlation. Okay. The correlation coefficient actually is going to go between 1 and -1. Okay, so -1 and 1. It can't be bigger than 1 and it can't be less than -1. The closer that R is to 1, the stronger the linear relationship, okay? The closer R is to 0, the weaker the linear relationship. If R actually equals 0, then there is no linear relationship, okay? There could be, again, one of those other types of relationship that we said could be quadratic, could be exponential, and there's a lot of other relationships that it could be, okay, that we're going to learn later this year. All right, I want to look at that relationship. So what I like to think about is here's 1 and here's -1, okay? And I'm going to put point 0 right in the middle, okay? So as R gets closer to 1, as it gets closer to 1, it gets a stronger positive relationship. And as it gets closer to -1, it's a stronger negative relationship. But by negative relationship, I don't mean bad. I mean that the slope, the line, the data is actually falling from left to right. Okay, so let's kind of break this up a little bit. Let's put like maybe negative 0.75 here, negative 0.5, negative 0.25. So I always think between -1 and negative 0.75, I'm going to call that a strong. Whereas between 0.5 and 0, those are weaker relationships, okay? And the same over here. If this is 0.75 and we've got a 0.5 here and then 0.25, I'm saying that between 0.75 and 1, it's a stronger positive. But anything below that is kind of a weaker, and we may not want to use a linear regression to relate to the data. Okay? All right, so for now, what I want you to know for tomorrow is I want you to understand what a correlation is, what regression is, and what the correlation coefficient, the R value, indicates. Tomorrow, we're going to talk more about how you actually do the correlation, how you do the regression, and find the R value. And then we're going to look at some data together and put it all together. So hopefully that gives you a little bit of understanding on correlation and correlation coefficient. Have a great night, guys.